Most of you are familiar with the next speaker, Dale Bardos. Just a little bit about his background. He's a research ecologist with the Forest and Woodlands Ecosystem Program, USDA Forest Service Rocky Mountain Research Station. That's the branch office here in Logan, Utah. He's also an adjunct associate professor with the Wildland Resources Department here at Utah State University. He's been very helpful in many graduate committees here, anything revolving around the subject of aspen ecology. He holds a BS and MS from Fort Hays State College in Kansas and a PhD in range science from Colorado State University in Fort Collins. Principal research interests are ecological processes in general and restoration of aspen landscapes. He's been working with aspen for the past 35 years in the Forest Service Research Lab here in Logan, and he's one of the few scientists in the western U.S. who is working on this critical species still. So let's have a round of applause for Dale Bardos.
Thanks, Paul. It is a pleasure for me to give this presentation. What I'd like to do today is tell you a little bit about the work that one of my students did, Andrew Coda. He was a master's student here at Utah State. He worked in the Black Hills. One of the most common questions I get asked is how do we protect our aspen when we have large numbers of ungulates out there waiting to eat it off. And so the ideal thing would be to come up with a disposable fence or an inexpensive means of keeping animals off of or out of the areas to allow the regeneration to be successful. So, like I said, Andrew did most of his work in the Black Hills of South Dakota. We're all aware of the importance of aspen, and this just indicates some of the more critical components that come out of the aspen system. And one of the main ones is more forage or undergrowth biomass. It has been shown that aspen produces much more undergrowth than conifer-dominated systems. And a recent paper, another student here at Utah State worked on, Martin Stam, that paper came out in Journal of Range in early this year. Also, it produces wildlife diversity, and as indicated here, Mark Grumble has done work on that in the Black Hills. Water is another component that is compromised when we see aspen convert to conifers in some instances. And so aspen generally is thought of as producing more water, whether it's going into the forage or soil profile or downstream. And of course aesthetics. Like I tell people, everyone knows what aspen is, and they have a really good feeling about it and for it. So when we have problems associated with aspen hitting the press, we get a lot of positive response from the public. So aspen regenerates in two main ways. Sexual reproduction produces seeds. When I first started here 35 years ago, the idea was that aspen did not produce viable seeds, and there wasn't such a thing as an aspen seedling in the West. In fact, a university back east had offered a reward for anyone that could find an aspen seedling. But since then, we have found numerous occasions of seedlings coming on site, but still most of the regeneration of aspen is on a clonal basis and comes about as root suckers coming from the shallow root system that we have associated with aspen. This is a diagram or animation of what's happening in the suckering process. But anyway, what was happening there, you saw the green line showing translocation from the parent tree down the stem into the root systems. And what's happening there is that you have a balance of hormones in the tree and the root system. You have the tree producing auxins, which is pumped to the root system, which suppresses the cytokinins that are existing in the roots. Once that flow is stopped, then you get the cytokinins kicking in and you get the suckering response in the roots producing the new suckers. And that is the primary way that aspen regenerates here in the West. And that is the case most everywhere. The study site that Andrew worked on was in the Black Hills, elevation of 2,150 meters. Most of the aspen occurs on mesic sites, primarily along streams and usually on north-facing slopes. There's been approximate 40 to 50% decline in aspen in the Black Hills itself. And as you see here, less than 4% of the land mass is covered in aspen, and that's like 15,500 hectares, which is a very small portion of the trees on or in the Black Hills. Both Severson and Thelenius found that there was approximately 5%, that was back in 1976, and then Rumble later on and his associates projected 4%. So it's right in that area, 4 to 5% of the hills. And some have projected a decrease of about 1% in the last 20 to 25 years. Okay, what happens with, this is an animation of aspen decline. You see the aspen being taken over by the conifers. And this is probably a situation that takes place over about 100 years of looking at it. And this is where we're seeing the decline. This is one of the questions I had for Scott Bell, is that has anyone started looking at trying to get rid of this conifer component? That would be a great opportunity for someone to make a lot of money finding something to do with the subalpine fir that has taken over the aspen in this part of the country. Now in the Black Hills that isn't the case, it's ponderosa pine, but it still works the same way. Why do we have this decline? One reason is fire suppression since European settlement. Then on top of that, we have a lot of use in some areas by wildlife and domestic ungulates. Most of the aspen is favored by elk and deer, primarily during the winter months. And in areas where livestock congregate or have no other or not a lot of other forage to consume, that they will turn to aspen. And then in the Black Hills, it's interesting enough that management has been responsible a little bit for this decline. There was an effort in the mid-50s and 60s to eradicate aspen and plant ponderosa pine. 95% of the landscape was pine, but they were going to plant the other 5% to aspen also, or to pine. We do learn some things over the years. This is just an example of aspen suckers that are repeatedly browsed. This is indication of what's happening, and you can see the terminals are taken off here, and that is not allowing the tree sucker to grow into a tree. And if you keep getting this repeated browsing, then you get a shrub-like growth form. This just shows, I'm going to talk about 3 different sites in the Black Hills, Silver Mountain, Jasper, and in Custer State Park. This just is an animation of putting fire back into the system and what happens with the aspen. And this is, I really do appreciate the person that did these animations. He did an excellent job on that. And one thing which I think he grasped and showed very well is that we get this expansion of the footprint of the aspen if things go right as a result of treatment. Like I said, there were three main areas that Andrew looked at. Silver Mountain, which was a natural burn that occurred in 2002. The Jasper fire, which was a big 80,000 acre burn that happened in 2000. And then in Custer State Park, he worked on an area there that was treated in 2004. So he was looking at various ways of keeping animals out of these treatments, and the first one is total wildlife exclosure. Please ignore that. It's not an exclosure of aspen, it's a wildlife exclosure, but didn't have anything to do with the signing. But this is an 8-foot tall woven wire fence that keeps virtually every animal out of the area. And as you can see, it's quite expensive. And so another one, the second one is just a regular livestock type fence, 3 barbed wire, approximately 3 feet tall, to keep all the smaller livestock or animals out, like cattle and bison, but it allows deer and elk into it. One of the main ways that Andrew was looking at protecting aspen regeneration was a technique called hinging. And this is where the pine or aspen are cut at a 3 to 4 foot height and kept on the stump, and so you get this layering that you can create barriers around your aspen regeneration. The use of dead aspen was found not to work very well because if it has been standing in a length of time, it is very brittle and you can't keep it on the stump. The best way of doing it is with live pine, and is fairly easy to keep it on the stump. This is just a diagram of the way this works, and you see you get this sort of a pin appearance of the hinging around the outside, and allows the regeneration to be sort of saved from the ungulates in the area. And he found that the best materials was live pine with needles on, dropping, and this in fact created a visual barrier to the animals to see the aspen in the center of the area. So something to keep in mind. This is just some examples of the hinging. One thing I would recommend, as I mentioned earlier, I was talking about how the Forest Service is safety minded. This is something that you need to be having someone do that knows what they're doing with respect to cutting trees. It's sometimes difficult for people to be cutting at head height on trees, so something to keep in mind. Another method of protecting aspen regeneration is just slash, using down material or finer materials, creating piles or barriers of barriers to protect the aspen. And this has been used in numerous areas and places in the past, and has been found to be a fairly effective way of doing it. So this is just examples of slash treatments. And the one thing that we would recommend here is that you don't stack the slash too deep, because if you do, then you get the shading, and you minimize suckering response and growth potential of the suckers. I think Mark Rumble has a paper out that he did in the Black Hills on slash, giving recommendations on the depth of it. So those are the four main treatments we used, and then he also looked at areas that were not protected at all. So the main research objectives of this project was to primarily look at these four different barriers, but the two main ones is the hinging and slashing, which I'd like to talk about today. We pretty much know that total wildlife exclusion excludes most all utilization of aspen regeneration, and livestock fencing protects from those that are kept out from there. The two main things that we're concerned about here is the slash and the hinging. Andrew just divided the suckers into three different classes: less than 50 centimeters, 50 to 100 centimeters, and then over 100 centimeters. And the main reason I'm going to talk about this third category in a minute, the suckers over 100 centimeters. He also did an evaluation of the amount of browsing on the various suckers. Whether the terminal was just clipped off, or side branches, or if leaves were stripped off. Different animals utilize the suckers in different ways. And then he did an evaluation of the use by ungulates, and this is just fecal pile that was counted. The animals up there don't defecate in pink tones. He sprayed this so that he would know that he had counted this in previous years. So. This just, I'll get into a few results right now. This just gives you an idea of the amount of regeneration suckers per hectare that found on the various sites in May of 2004. You can see sufficient numbers of regeneration there to repopulate these stands, both in all three areas, actually. The Custer site was stimulated by some of the treatment activities, and therefore there was a little bit more regeneration there than had been anticipated. But as you can see, that is sufficient numbers of aspen on site to restock the stands. Found a decrease in the overall average terminal amount removed per sucker and it went from 21 centimeters in 2004 down to 14 centimeters. So overall, the treatments added to a reduction in the amount of browsing over the area. The lowest amount of removal was in August of 2004, which was 11 centimeters. This is an indication of the browse 1 year post-treatment. This is an establishment of the barriers, not the treatment of the burn or whatever. The four different treatments: hinging, livestock fencing, slash, and wildlife. And as you can see, as anticipated, the wildlife fencing did a very thorough job of reducing almost all the browsing on the regeneration. And as you can see here, the hinging did a fairly good job of only allowing 40% of the suckers to be utilized, and then livestock and slash was a little bit higher. no matter how good a fence you get, there are ways, animals find ways of getting in there. This, I was talking about the third size class of suckers, and this is just the amount of suckers in that 100 centimeters plus height class. And this just shows that in the hinge area, the most of the size class 3 existed, were found to exist in the hinge versus the other ones. And I'll speculate on that in just a minute. Okay, that did show up. I was afraid it wasn't going to. This is just a comparison of the cost of doing these treatments. And, I guess if you have an animal problem, the ideal way of protecting your regeneration is by establishing 8-foot tall woven wire fence, which would preclude any large animal from getting into the area. But of course, that can be very expensive, and most managers don't have those kind of resources to apply those on the ground. And then even using the livestock fencing, it's not that cheap to get that in place. Hinging and slash, of course, is fairly inexpensive, and I think you can get probably the biggest bang for your buck doing these kind of treatments. So the conclusions coming out of this, that all the treatment barriers that were constructed in the study decreased the amount of browsing on the aspen suckers after a year when compared to the control. Of course, the wildlife fences decreased browsing to almost zero. Hinging decreased browsing more than livestock fencing and the slash barriers. And both the slash and the livestock, as was shown, reduced the average percent of use on suckers about the same after a 1-year period. Most of the aspen suckers were used during the winter, and this is an indication that wildlife, primarily elk in this instance, was the primary consumer of these regeneration. And most of the terminal leaders on the suckers were taken off, and I'll show you a picture in a minute of what comes about as a result of that. In areas where there was excessive high numbers of deer and elk, the wildlife fences might be the only viable way of protecting regeneration. However, if you have you do have other means that you might be able to use, such as a slashing and hinging, to protect some of your areas. And there is a significant size class 3 difference shown here among the treatments. And part of this, Andrew was speculating, is maybe an increase in soil water retention and decrease the evapotranspiration because of the shading. Now, okay, just a couple of recommendations. The size of the hinge and slash treatments are very important to the managers. Not large areas need to be done, maybe a quarter of a hectare, and maybe a little bit smaller on slash treatments. Large patch areas should be broken into smaller areas, like indicated, and because if you do large areas, the animals might be attracted into these areas for cover and safety. Okay, so what has happened out there since 04 or 05? This is just an example of the elk exclosures. This is the way it looked in '03 when they were first established. And this is what it looked like just last week, I guess. The fence goes right down along there. And this is a very obvious inside-outside situation. I had one of the South Dakota Game and Fish people take these pictures, and most all of the ones that have a total exclusion have this phenomenon going on, total elimination almost of aspen regeneration outside. This is what the suckers look like inside. The slash treatments, you can see what it looked like in '03, shortly after areas were established, and then in '08 you can see regeneration surviving in some of these areas. But then of course there are pockets where it has been taken out. Here again, in some of the areas, instead of doing woven wire fencing, they use buck and pole fence. And again, very marked difference there between inside and outside. Hinging treatments, this is just one that was done in '05. Keeping it on the stump, getting it down, giving some protection. And this is what it looked like in May of '08. The suckers are not in leaf, but you can see that they are there and have been afforded some protection as a result of the hinging. And then the livestock fencing just shows how it looked like in '04, right after the fence was constructed. Here you got good regeneration both inside and outside, and this is, again, I think this is inside, that's outside, but fairly good uniform regeneration on both sides of the fence. In this particular area, elk are not a large problem, as was seen in the other areas on the Jasper farm. I'm glad I got to the end because I'm drying out considerably. That's basically all I have to say, so I'll take some questions. Yes.
Question. With this hinging and slashing, the big game getting in there, does that stuff last long enough to get suckers up or high enough where that they're going to get above browse height or get where they'll survive?
In most cases, yes. Of course, if you have some areas that are the aspen are slow growing, then it might not last so long enough. But I see 2-3 foot of growth on aspen a year. Some areas you get up to 6 foot. So if everything works like it should, then that shouldn't be a problem. Yeah, it might be in certain areas, but overall it shouldn't be. Yeah. Yeah.
You talked about the size of your treatment units, and I guess I'm more of the school of thought that bigger is better. Ungulates get dispersed over larger areas, so their impact on a particular area is smaller. Did I mishear you, or? No,
I was just referring to the hinging treatment and the slashing treatment. You don't want to try to do a 90-acre hinge treatment. It would be virtually impossible. There isn't enough resources out there to do that. The Black Hills has done a considerable amount of hinging on the forest since this study has been done, and they did like 90 acres in one area, but they just did pockets within that, and that worked quite well. Ideally, if you're treating aspen to minimize animal impacts, 70,000 to 80,000 acres is what you need to be doing. The Jasper fire was 80,000 acres, I think, but almost every bit of that that's not protected has been hammered by animals. Yeah.
You showed a nice picture, a nice diagram of the hinges forming a nice little box. How do you directional fell the trees when you do that? It seems like it must be very dangerous.
That's why I recommended having sawers that know what they're doing. Most of these that they were hinging were, less than 10 inches in diameter, so a fairly small tree to work with. And it wasn't that difficult to get them down. If you know what you're doing, you can get them going in the right direction. And the ideal thing is that you have to make a couple concentric rings or areas around an area. First you get them coming down like this, and so you can get this crossover all the way around, and that works quite nicely then. Yeah, Paul.
I know this is a little beyond the scope of the study, but I'm just curious about the differences, if you're aware of any, between deer and elk in terms of their palatability and how much they're utilizing these aspen suckers.
There's enough blade to go around for everything in certain areas. I've been to areas where elk are the prime users, and then there are other areas where deer are a big factor. Overall, if I was giving my overall evaluation of what I've seen throughout the West, elk are your primary users of Aspen Regeneration. You get in some areas and it's livestock, but it all goes back to, yes, there is a preference, or I feel that there is a preference, animals from clone to clone, in fact. You'll see some clones that are completely consumed, all of regeneration, and one next to it will not be consumed or utilized at all. And so I don't think I really answered your question, but by and large, I would say most of the damage done by wildlife in particularly this part of the country is probably due to elk, mainly because deer numbers are down in a lot of areas. So, okay. Yeah.
Could you comment on another slash treatment where instead of trying to cover everything with slash, you basically build a slash barrier?
Sure.
It's too dense and wide for the elk to get.
Right. Yeah.
Is that feasible or effective?
Yeah, it's very good on if your problem is livestock, because you get any kind of barrier out there at all, and they're not going to try to penetrate that. And if you do, and I think Mark Rummel probably did this in his study up there in the hills, do a wider area of slash and protecting, create a donut of slash, and that works quite nicely.
You don't think it would work for elk if you made it wider?
Well, yeah, it would. Yeah. Although there's any kind of a way in there, they're going to be getting in there. Yeah.
Okay, Dale, thanks very much.
Sure.